Patrick.
Hey.
How you doing today?
I'm doing good. How are you?
Good. All right, so looks like we're doing, what, anywhere from an hour to an hour and a half today?
Yeah, depending on what he needs to get through those items, David. And we don't need to use the cell phone because I fixed that go-to-meeting, right? You can hear us clear?
Yeah, the audio is very good.
Yep, and we can hear you clearly too. So as I told you, I've got a doctor's appointment, so I'm sort of going to leave it between you two as to how much you think that he needs, you know, going through those things. He's got a test coming up tomorrow, so I'm trying to get him prepared on it.
Okay, and there's just one sheet of paper here that goes through question 22?
That's it, David.
Okay.
And he circled some, I guess, that, you know, maybe you could just go over the beginning ones quick, but I think he circled the ones that he's got the problems with, and with that, I'll leave you guys alone.
Sounds good.
Thanks, David.
All right, David. Okay, Patrick, I noticed some of your answers on the first question aren't right. So maybe we need to look at question 1 also. If I were to write that function in standard form, what would it look like?
Why don't you just put it in order for like the 5x to the 4th and 9x to the 3rd?
Yes. Okay, so you make sure you bring the sign. It's minus 9x to the 3rd. What's the leading coefficient?
Wouldn't that be 5?
What's the degree of the polynomial?
Crap, I forget these. I forget the name for them, but it's 4.
It's 4. Well, that's the degree of the polynomial is 4. Classify the polynomial by the number of terms and the degree. How many terms are there?
4. So wouldn't that be quadratic polynomial?
It's not quadratic. Quadratic is x squared. X cubed is cubic. And x to the 4th is quartic. Okay? So that would be there's 4 terms and it's a quartic.
All right.
All right, let's look at number 4. Let me move it up a little bit.
Okay.
Is that n to the 3rd?
Yeah, let me just get my sheet. Yeah, that's into the 3rd.
Just want to make sure I can't read it terribly good. So how do I multiply those two together?
Hold on. Don't you multiply the like terms?
No, actually what you do is you take this term and multiply every term by it.
Oh, all right.
So what is this term times this term?
Just kind of shooting in the dark here. Would be negative 40 and the 4th?
You add the exponents?
Oh, all right. So it's 40 and
Yeah, let's go over those rules. If I have any number and I multiply it by the same base, different exponent, what does that equal to?
that would be 9 to the 9.
It's 3 to the 9th.
Oh.
In other words, b to the x times b to the y is equal to b to the x plus y.
Oh.
So if you have the same base multiplying together, then you add their exponents. If you have, and the base here is n, not 5 and 8, that's the coefficient. But the base is n. So if I multiply 8n cubed times 5n squared, I'm going to get minus 40n to the 5th, because I'm going to add their exponents. So what's the second term?
Would that be 24n to the 4th, or would it be 24n to the 3rd?
24n to the 4th is correct. What's the sign in front of it? Because I cannot ignore that. In other words, I can't leave it blank. I can't just leave it blank like that and write
Would it be plus?
24n to the 4th. Yeah, it would be plus, because the minus times the minus is equal to a plus. And finally, what is the third term?
I'm not sure how you would multiply a whole number by that.
Well, just multiply the numbers.
Oh, all right. So do you add the n to the 3rd onto the end of it if it's a
Yeah,
whole number?
you do. In other words, this is the same problem as 7 times 8n to the 3rd. Well, you really just need to multiply the numbers. Minus 56, and you bring forth the n to the 3rd.
All right.
Okay? So really multiplying these things is relatively easy. What it's called doing is distributing this to each term. All right, let's look at number 5. X plus 5 times x minus 9. Have they taught you something called FOIL?
No.
Good, because I don't like FOIL. What I prefer is ET. Every term by every term. What does that mean? That means that if we're multiplying two terms by two terms, we're going to multiply that times that, and then we're going to add that times that, and then we're going to multiply that times that, and we're going to multiply that times that. Now, some school systems call this FOIL because that's the first, that's the outside, that's the inside, that's the last. That's what FOIL stands for. First, outside, inside, last. The thing I don't like about FOIL is that it only works for two terms times two terms. If you have two terms times three terms, it doesn't work. And yet, every term by every term does. So, no matter how many terms you have, as long as you do every term by every term, you'll be fine. So, what's the first term that I get as a result?
Wouldn't that be x squared?
Next.
That would be negative 9x
Next.
plus 5x
And last.
minus 45.
Your skills are getting better, Patrick, I can tell. Simplify that.
Crap. Let's see, that would be x squared minus negative 4x.
Okay, it's just minus a 4x. It's not going to be minus a minus.
Sorry.
Just one minus, because if you put two minuses there, it's going to turn into a plus. Okay, good. All right, now, this is the reason they don't teach FOIL anymore. Because FOIL, first, outside, inside, last, does not work when you have a binomial times a trinomial. But ET times ET does. Every term by every term. So what's this result?
Hold on. So that would be 6x to the third.
Okay.
And then it would be negative 12x.
12x squared.
Oh,
Because
sorry.
3x times minus 4x, you multiply the numbers and you multiply the variables.
Then minus 27x. And then plus x squared.
Okay, we're going to multiply 1 times 2x squared, so that would be plus 2x squared.
Oh, all right. And then minus 4.
Minus 4x. Again, we're going to multiply 1 times minus 4x.
All right. And then negative 9.
Okay. Now combine like terms. Now you're always only going to have one of these. There's only going to be one x cubed, and it's that one. But usually you have a couple of x squared terms. Combine those.
So it would be negative 10x squared.
And the x terms.
And that would be, would that be negative 31x?
And the number, you usually only have one number also in this case. So there's the answer.
All right.
Okay. Now number 7 is 2x plus 1 quantity squared. How do I do that?
Hold on real quick. I'm just changing my answer.
Sure. Uh-huh.
All right. So number 7 would be. I had problems with this. How would you square that?
Okay, squaring means to multiply by itself. So that's the same thing as squaring 2x plus 1.
So would it be 4x to the 4x squared plus 2?
Multiply every term by every term.
So it'd be plus 2x, and then that would be plus another 4x squared.
No.
Oh, sorry.
Here's what I'm going to do. I'm going to do that times that, and I'm going to do that times that, then I'm going to do this times this, and then I'm going to do this times this.
All right.
So you got the first 3 of them done. What's the final term?
It'd be a 2. I mean 1. Got it. Sorry about that.
Now combine like terms.
So it'd be 4x squared plus 4x plus 1.
Good. Now, this is a special kind of binomial times binomial. Notice the only difference between these two terms is this is plus and this is minus. It's worth, let's go ahead and multiply this out, and I'll show you what I mean, but it's worth knowing that whenever you have this situation, you lose both two middle terms. And I'll show you why. Let's go ahead and do it.
So the first one
5 times 5?
would be 25. And then the next one, would that be 10z?
Minus 10z. In other words, I'm doing that, and then I'm doing that. Now I'm going to do this, and then this.
So then we plus 10z. 10 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 And then we'd have
what's plus 2z times minus 2z?
would there be negative 4z squared?
Yes. And notice the middle two terms cancel. And they will always cancel, as long as it's like a plus b times a minus b. You will never have those two middle terms. You will just end up with the first term and the last term. And it's worth noticing that, because at some point you'll get to a point where you can do that faster by ignoring the two middle terms and just going for the first term and the last term.
All right.
So, what's the perimeter of a rectangle? Let's put numbers on this first. If I had a rectangle that was 5 by 3, what's the perimeter of that?
That would be 15.
No? In other words, if it's a rectangle, this is 5 and this is 3 over here. What's the sum of the outside?
That would be 16.
Right. So when I give you just those two numbers, then it's 2 times 5 plus 2 times 3. That's how we got 16, right? Okay. Now let's substitute variables. So if it's x plus 7 and x plus 2, what's the perimeter equal to?
Wouldn't there be x plus 7
Times 2.
and then that would be plus x plus 2 times 2.
Right. Okay, now let's simplify. What's this part become?
Becomes 14x.
Multiply the 2 by both terms.
Oh, so it becomes 2x plus 14.
Uh-huh.
That would be plus 2x plus 4.
Okay, now simplify.
That would be 4x plus 18.
Wow, I can see why you haven't been using me lately. Your skills are getting better. Are your grades getting better? Yeah, I thought so. That's good. That's great, actually. Okay, so what's the area of this rectangle going to be?
Wouldn't that be x plus 7 times x plus 2?
Yeah, and that is the right answer there. The perimeter was not right. In other words, you want to erase that and replace it with what we came up with, which was 4x plus 18. But the area is right. When you multiply it x plus 2 times x plus 7, that's what you get. If x equals 4, what is the area of the rectangle? Okay, that's correct. In other words, you plugged in 4 into this, right, for x?
Yeah.
And you got 4 squared plus 36 plus 14, and you combine that to 50. If I wanted to make sure the teacher knew exactly what I was doing, I would have written this like this. See the difference?
Yeah.
You put the same thing, but you skipped a step by combining those two. And your teacher probably sees that. Probably going to not take away anything from that. But it's always best to make sure your teacher knows precisely what you're doing. Show more steps rather than few. You know what I'm saying?
Yes.
A lot of teachers, they can't figure out that what you did there. So if you really want to make them know for sure, then merely plug in 4 for x and write it exactly like that. Okay, when we are finding a greatest common factor, which is a big skill because you have to do this a lot. You have to do this for almost every math course you take. You have to do it for the SATs, the ACTs. This is a big skill here. So, what does it mean to find the greatest common factor?
To find the greatest common factor between the two. Like,
what we're looking for is something that divides evenly into both that and that. That's what we're looking for. So let's look at the numbers first. What's the biggest number that divides evenly into both 8 and 16?
8.
Good. You with me?
Yeah.
What's the biggest x factor that divides evenly into both of those terms?
Could be 4.
Just x. X goes into this once, and it goes into this twice. So I can take out an x. What's the biggest y that divides into both?
Y.
Y squared. Now, the thing about finding a greatest common factor, the step you want to take every single time is to multiply these two things back together and make sure you get what you started with. In other words, if I multiply this times 1, I get this. And if I multiply this times this, I get that. If you've done it correctly, you will always get the same thing. If you've made a mistake, you won't. Notice that when I first did it, I left out the x, because I forgot to divide this thing by x, which results in an x. In other words, when you're finding a greatest common factor, what you're doing is taking this greatest common factor and dividing it into that term and that term. Well, when I divide it into that term, I get 1. When I divide it into this term, I get minus 2xy. And you can check that by multiplying it back. And when I multiply this times 1, I get this. When I multiply this times this whole thing, I get this. That's what greatest common factor is all about.
All right.
What's the greatest common number that goes into each of these?
It's 2.
What's the greatest letter?
Could be
Variable.
Could be x.
Once I divide each term by 2x, what do I have left?
You have a 1x.
Hold on, what's that?
Would there be x cubed?
Yeah, x squared. Let's review that. Hold on.
All right.
If I have x to the 5th divided by x to the 2nd, what does that equal to?
Would be x to the 3rd?
Yeah, you subtract exponents. In other words, when I'm multiplying, same base, different exponents, I add the exponents. When I am dividing, same base, different exponents, I subtract the exponents. And the third rule is if I am double exponentiating. That's what I call double exponentiating. What do I do with the exponents?
You add them?
Multiply.
Okay.
Notice that everything I did was one step mathematically less. In other words, when I was multiplying, I added. When I was dividing, I subtracted. So I'm never doing the same thing with the exponents that I'm doing with the base. I'm always doing one level less, in the sense that addition is one level less than multiplication, and subtraction is one level less than division. Well, when I do double exponentiation, the level that is less than that is multiplication. So these are really the only three rules you need to remember for exponents. When you're multiplying, and it has to be the same base. So if I had this, what's that equal to?
That would be hold on real quick.
Same base, 4. And I'm multiplying.
So it'd be 4 to the 5th.
Exactly. What is this?
That'd be 5 cubed. I mean 5 squared.
Yeah, very good. Because there's an implied 1 right there. So you have to subtract the exponents. And finally, what is that?
It'd be 6 to the 8.
Okay. So let's go back. We finished 11?
No.
What's the greatest total common factor I can remove from this?
2.
2x. In other words, look to both the number and can I remove a variable? And yes, because I can divide every term by x. In fact, I can divide every single term by 2x. Okay, and it leaves that. What's next?
Plus would be an 8x.
Remember, it's got to multiply back together to give you this. So how you come up with this is to divide 8x squared by 2x.
So it'd be 4x. And then minus 2x.
Minus just 2. Now, check that to make sure that it is the same as that. In other words, when we multiply this thing back together again, we get 2x cubed plus 8x squared minus 4x. Is that the same? It is. So that's always a step you want to take, because that'll pick up any mistakes you've made. Okay? What's the biggest number greatest common factor?
It'd be 4.
So there's a 3 there and a 4 here. What's the biggest x that'll come out of that?
X squared.
And what's the biggest y?
Y.
Okay. So what completes that term there?
3 to the 3x squared,
Good.
which and that would just be on y.
Good.
And then it'd be plus 4, just plus 4.
Good. Very good. In 14, which of those are polynomials?
Let's see. It'll be A.
No? To be a polynomial, you have to have a positive integer as an exponent. This has a -1, so it does not qualify as a polynomial. How about B?
No.
No, B is. Because it's got a 3 for this exponent, for this variable. It's got a 1 for that exponent, and it's got a 2 for this exponent. So it's not the coefficient that matters, it's the exponent on the x term. How about C?
Yes.
No? Remember, the exponent on the x term has to be a positive integer number, a whole number. That's as a half. So that is not a polynomial. How about D?
No.
You're right, no. In other words, this would be okay, and this would be okay, but 5 to the x has the x in the exponent, not on the algebra line. So that's not a polynomial. In other words, it has to have nothing but x's on the line and positive exponents. All right, let's talk about factoring. I've been having some issues with factoring. And the issues are that I think I know how to factor better than the school system teaches most people how to factor. What do they teach you? Did they teach you the California method, the diamond method? Did they call it anything?
They didn't really call it anything.
Okay, good. Because that's my method. I don't call my method anything either. But I'm 100% convinced that it's better than what they teach and they call the California method. California method is something that's so hard, so complex, so confusing that I've met very few students who can remember it. So I always factor using my own techniques. And my own techniques have very specific steps. And if you learn each step, you will be an expert at factoring. But if you skip some of the steps, you'll have problems. So the first step is to figure out what goes here and here. In other words, what will produce x squared? X times x, right?
Yep.
Okay. Step 2, and this is very important. This is the one where most of my students fail, is they forget to do step 2. Step 2 is to determine what the signs are going to be. In other words, what is my sign? Is it going to be plus or minus there or plus or minus there? How do I figure out what those signs are going to be?
Well, the way we learned it, which two numbers would equal, when added up, would equal negative 17, but times to get plus 72.
All right. I don't have any problem with that, but it kind of omits step number 2. If you learn step number 2, the way I understand it, I examine the sign on that number right there. Because it is a plus, both of my signs have to be the same. They either have to both be negative or they have to both be positive. because that's the only way you can produce a plus 72, is by having both signs the same. Now, are they both negative or both positive?
They're both positive.
They're both negative because the sign on the middle term is negative. So once I figure out that they have to both be the same, I look to the middle term to figure out what they have to be, negative negative or positive positive. Step 3, factors of 72, not plus 72, but 72. By factors, I mean two numbers that multiply together to give you 72. That add, because of that plus sign, to the number 17. Well, that would be 9 and 8. And 90% of factoring problems are going to be this simple, that you can use those 3 steps. Okay?
All right.
Let's look at 17 before we do 16. Because 17 is the same as 15. Let's go through each step. And as stupid as this may sound, I want you to tell me all 3 steps in order, because if you learn these steps, you will learn how to factor every quadratic. If you fall back on what your school taught you, I don't know what will happen. So what's step 1?
You put the x's.
What's step 2?
You figure out what the sign would be.
What are the signs? Not the sign, but the signs. In other words, I need to figure out what that's going to be and what that's going to be. What's this plus sign tell me?
One of them is plus.
Both of them are the same. Remember, you produce a plus by multiplying 2 negatives together or 2 positives together. If these signs were opposite, I would necessarily have a negative sign there. So whenever I find a negative sign there, I know the signs are opposite. But when I find a positive sign there, the signs are the same. And what are they? Both plus or both minus?
Both minus.
What's the third rule?
And you just figure out which one factors in the...
Factors of 9 that add, because if this is a negative, then they're going to need to subtract. But in this case, because it's positive, I want factors of 9 that add to the number 6. Not the negative 6, but to the number 6. It's that simple. Well, that's 3 and 3. And that is the way you're going to factor 90% of quadratics. Okay? Now, let's look at 16. Let's try, let's not end it there. Let me do one more here. You just can't hardly get too much practice on factoring. It's the one area that people seem to have the most difficulty with. So, what are the signs?
They'd be opposite of each other.
Yeah, and it doesn't matter if I put the plus here or the minus there. As long as the coefficient of the x is 1 and 1, then as long as the signs are opposite, I can put them either way. Now, the rule says you want factors of 10 that subtract to the number 3. Not add, but subtract because of that negative sign right there. So the sign on this constant is huge. That's the most important sign when you go to factor a quadratic. It's the sign on the constant. That tells you what the numbers are going to be, and it also tells you that you want factors of 10 that subtract to the number 3. Well, that would be 5 and 2. Take the largest factor, 5, put it with the sign of the middle term, the negative. Now, there's one last step when I factor, and this is key. In fact, this is huge. I don't need to check to see if that term is correct. I don't need to check and see if that term is correct. The way I did my factoring, I came up with x and x based on the fact that it came to x squared. And I came up with 2 and 5 based on the fact that it multiplied to minus 10. The only term that I really want to check is the middle term. Well, the middle term is produced by multiplying the 2 inside terms and the 2 outside terms. I kind of call this my double smiley faces. Add them together, that needs to be our middle term. It is. Therefore, we did it right. So you can be certain that that's the right answer. Notice that if you have a cubic trinomial, which is what this is, the y-intercept is always the constant. Why is that? Because the y-intercept is where x is equal to 0. Well, if I plug in x equals 0, all three of these terms disappear. And I'm left with minus 6. So it's all I have to do to come up with a cubic trinomial with this y-intercept is I can put any term I want in these three spots. I could have put a 4x cubed and a 3x squared and a 1/2 x. Wouldn't matter. As long as this term was minus 6, that's my y-intercept. Okay? Now, we forgot one here. I just realized we didn't do number 16. Now, 16 is different. Why is 16 different?
It doesn't have a second term.
Doesn't have an x term. Well, whenever you see this, think one thing, and that is something called the difference of what? This is called the difference of perfect squares because that is a perfect square, that is a perfect square, and I'm taking the difference of them. And this is another big thing you're going to have to do many, many times. So you want to get to the point where you recognize what difference of perfect squares means. Now, what does it mean? It factors this way every time. In other words, if you have the difference of perfect squares, this has to be it, a squared minus b squared is the difference of perfect squares, well, it always factors into a minus b times a plus b. If I multiply a minus b times a plus b, I'm going to get a squared minus b squared. Okay?
Okay.
So when we have x squared minus 25, is all we have to do is figure out what is a and what is b. Well, what's a?
Well,
A is x. A is the square root of that. What is b?
5.
Square root of that. So what does this factor into?
X equals 5.
X minus 5 times x plus 5. Notice that you want to end up with a minus b times a plus b. So the only thing we needed to figure out was what was a and what was b. Let's do another one. These are so important that we need to do more than one. What's a? What's b?
It would be 2x squared.
Just 2x. Remember, I'm taking the square root of that. 2x times 2x would be 4x squared.
All right.
What's b?
And then 6.
How does this factor?
It'd be 2x minus 6 times 2x plus 6.
Excellent. That's the difference of squares in a nutshell. But it's real important. I mean, it's something you really are going to... It's as important as the Pythagorean theorem is. So I'm going to give you some here. This is the one that most people don't recognize because they don't think of 1 as being a perfect square, but it is. Square root of 1 is 1. So how does this factor?
X minus 1, x plus 1. That'd be 9x minus 8x.
Just 8.
I mean 8. Sorry about that. Then it'd be 9x plus 8.
Excellent. If I have a function that has x-intercepts, at that point, minus 4, and at this point, plus 2, that means my function could do something like this. In other words, if the only thing I know is the x-intercepts, and there's 2 of them, then we're talking a quadratic, and it's probably a parabola. Let me redraw that. It's a parabola that's going to go like this. Okay? Well, if my x-intercept is minus 4 and 2, then my linear factors are x plus 4 times x minus 2. In other words, I know that this quadratic function is a result of multiplying these 2 things together. So multiply those 2 together, what do you get?
You get negative 8.
Well, x squared, got to ET them.
Sorry about that. So x squared minus 2x and then it would be plus 4x minus 8.
Simplify.
Well, it'd be x squared plus 2x minus 8.
Now, notice that just like every other function, the y-intercept is going to be where x equals 0, right? I mean, at this point right here where it crosses the y-axis, by definition, x is equal to 0 there, right?
Yeah.
So the y-intercept is always this constant, minus 8. Because if I plug x equals 0 in, I end up with minus 8. So that's all there is to problem 19, is to figure out, these are called the linear factors, and they're based on the fact that I know that the zeros of the function occur at minus 4 and 2, so the linear factors are x minus a minus 4, or x plus 4, and x minus 2. So if I multiply those two linear factors together, I get the quadratic that represents that function. And the y-intercept is always the constant.
All right.
Just take a quick look at this. All right. You should be able to wrap this up quickly here. Now, 20 is a little different because it's not a quadratic. We know that quadratics are parabolas. In other words, quadratics look like either this or they look like that. They don't ever look like this. When you have something that has two humps, in other words, a peak and a valley, it's a cubic. It's going to start with x cubed. Now, the general format is going to be y equals some constant times x minus p times x minus q times x minus r, where r, p, and q are your three zeros. We can assume a is 1. We don't need an a. So here's what we're looking at. Well, what are my three zeros? What's this 0 right here?
Sorry, the graph is just tiny.
That's minus 2.
Oh, I see.
So that becomes x minus a minus 2, which is x plus 2. What's this 0 here?
That's 1.
So that becomes x minus 1. Remember, it's always x minus the 0 value. And what's this value here?
That's 4.
So this is how I'm going to construct the function, is by multiplying these three linear values together. Now, this isn't that hard to do, but it can be a little tricky. Do the first two. In other words, that one times that one.
So it would be x squared
Okay.
minus 1x. And then it would be 2 plus 2x. And then it would be minus 2.
Simplify that expression.
It would be x squared plus x minus 2.
Now you have a trinomial times a binomial. And this is where foiling wouldn't really work, because foiling only works when you have a binomial times a binomial. But ET does work. Multiply every term by every term.
So it would be x cubed plus 4x cubed.
Minus 4x squared.
Minus 4x squared, sorry.
In other words, when I go every term by every term, I'm going to go like this, and then 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 like that. And I'm always going to maintain that pattern. I'm not going to mix it up, because when you have like a trinomial times a trinomial, you have a lot of steps. And if you randomly jump around, you could forget one. So it's very important to maintain the methodology. In other words, always do this term and multiply this term by every other term. And then do this term and then do this term. So what's the third term going to be?
It's going to be x squared. What's x squared? Minus 4x. And then minus 2x. And then plus 8.
Simplify.
All right, give me a second. X cubed minus 3x squared. And then minus 6x plus 8.
Patrick, I am impressed. I really am impressed. It's like you've advanced a year in 2 weeks. Let me just look at these last two questions here.
All right.
Let's do 22 first. We can see that when we multiply 2x by this, we get this over here, right? Okay, so check to make sure that that's true by substituting x equal 2 and y equal 3 into this right here. Hold on.
All right.
Okay. So substitute x equal 2 and y equal 3 into either this or this. They're both the same.
All right. Give me a second.
Well, the first thing you really want to do is just to rewrite it. In other words, you really don't need a second, because what I want you to do as an intermediate step is this.
All right.
In other words, wherever you see x, plug in 2. Wherever you see y, plug in 3. Then we'll figure out what it is. But if you omit this step and you try to do it all at once, it can be, whoops, excuse me. In other words, I think this is a critical step right here. You see what I've done? Now the only question is to multiply everything out and make sure the left side is equal to the right side. What do we get on the left here? Let's do inside the parentheses first. What's this going to be?
4 plus 9.
So we have 4 times 13, so we get 52 on the left. What do we get on the right?
We get 12 for the first one.
Okay, 2 cubed. What's 2 cubed?
So 6.
No. Multiply 2 times itself 3 times. 2 times 2 times 2. Not 2 plus 2 plus 2, but 2 times 2 times 2.
So it'll be
Okay, so this is 16 there, plus 6 times 6, 36, 52. So that equals that. We've verified that we have the identity correct. Wow. I'm trying to figure out how to draw this. What they basically mean, without drawing it, is that the height of the bridge is modeled by y, and the length of the bridge is modeled by x. So when they say find the length of the bridge at ground level, they want to know, well, what is x when y equals 0? So if I merely plug in 0 for y, and now I have this equation to solve, I'll have the answer. It's the first thing I can do to simplify this.
You could
Multiply everything by -10. That immediately still leaves the left as 0, but the right is now much simpler. Now, what's going to make the product of these two things equal to 0? How, when you multiply two numbers together and get 0, what does it mean about at least one of those numbers? It has to be 0. In other words, one of the most fundamental principles of algebra is that if you multiply two or more numbers together and you get 0 as an answer, then one of those numbers is equal to 0. If I say A times B times C times D times E equals 0, the only way that can be true is if at least one of these letters is equal to 0. If they're all some number different than 0, well, then there's no way you can produce a 0 when you multiply all of them together. So this is a fairly huge principle in algebra. It's called the zero product theorem. It says that if you multiply two numbers together and get 0, then one or both of them have to be 0. So this becomes real simple. Because all I have to do is set that equal to 0 or that equal to 0. Well, when I set x minus 50 equal to 0, what is x equal to?
It's equal to 0. It's equal to 50.
50. When I set x minus 2875 equal to 0, what is x equal to?
2875.
Those are your two answers. That's where the bridge at a distance of 50 feet and at a distance of 2,875 feet, the height is going to be 0.
All right.
Now that's a relatively difficult problem. I don't particularly like it, the way they worded it. But it accomplishes the job. So, all right. We made it through that whole page, and you did excellent, Patrick. Really excellent.
Thanks.
Yeah, you're welcome. We'll end it there.
All right.
I will talk to you next time.
All right,
All right, bye-bye.